Here we are at lesson 3 for practice 1.3.2 for math 1. Okay, so now we're dealing with creating and graphing exponential equations. So same idea as what we did with linear, this time exponential. Now with exponential, the way we think about it is y equals our start number times the growth, and because we're multiplying, the shortcut is raising it to the power. Okay, we usually write it y equals a times b to the x. So a would be your y-intercept, where we start on the y-axis. B would be the number we're multiplying by. Okay, so looking at this, y equals 2 times 3 to the x. So our y-intercept is 2, and our growth is by 3. So y equals 2 times 3 to the x. So we start at 0 equals 2, right here. Okay, not 0 equals 2, but 0, 2, the point. And then we're going to time. So a good idea is to draw a table to help with some of that visualization. So we're timing by 3 each time, so that'd be 6. So we'd go 1 up to 6, about right there. 2, we times by 3 becomes 18, which jumps us up right to here at 2. Oh, a little over more. Okay, so it's a curved graph. To get a visual, this is what an exponential graph looks like, something like that. There are special types called decays that work this way when we times by a fraction. Okay, but that's kind of the main idea here. So we're gonna start here, keep going up, draw our arrow, and then we're gonna keep going this way down. Okay, so there's those. So let's clear those. That's the graph 2 times 3 to the x. All right. So now if we look at this one, 0.25 is like 1/4 to the x. So it's like we're dividing by 4 each time. So we start at 1,000, and then we're dividing it by 4. So y equals 1,000 times 0.25, or 1/4 to the x. So if I made a table, it'd be 1,000. Oh, wrong way. It'd be 0 at 1,000. So we'd go clear up to 1,000, which we'll call right here 1,000. There's 20 tick marks, so that would be 500. Okay, so we're going by like 50. Okay, so that'd be 100, 200, and so on. 300, 400, 500, 600, 700, 800, 900, and then 1,000 right up there. Okay, now we're going to times it by 0.5, which is going to throw things off. Okay, or in other words, we're dividing by 4. So 1,000 divided by 4 would give us 250. Okay, so we do have to go jump down clear to 250 at the next point. Then 250 divided by 4 gives us 62.5. So 62.5 would be clear down here. So with this one, it starts up high and comes down. Now it's not going to go below the x-axis. It'll keep going along that x-axis, because dividing by 4 will never get you below 0. Okay, that's kind of the idea behind that one. Alright, so we got that one now, right? Okay, so we graphed the first two. So now we're going to do some equations, and then we're going to graph them. So this time I think I'm going to do it differently. We'll go write every single equation, then we'll just be able to graph them a lot quicker and kind of see how they are the same. The population of insects doubles. Doubles means times by 2 every month. This particular population started out with 20 insects. So we think y equals the start, what we're timesing by, which is the growth, to the x power. So we started with 20 insects. We're timesing them by 2. We raise it to the x power. There's our equation. Okay, so y equals 20 times 2 to the x. Okay, now the next one, the half-life of rhodium, RH106, is about 30 seconds. So every 30 seconds it cuts in half. That's what half-life means. Okay, so we're timesing by a half. That's our growth here. It's dividing by 2, but we call it timesing by a half. Okay, we start with 500 grams. So we go y equals 500 grams times 1/2 to the x, because that's our growth. That's our starting point. That's our growth. We take our growth to the x. That's how we do these ones. Okay, so y equals 500 times 1/2 to the x. Okay, number 5. A stock is declining at a rate of 25% of its value every 2 weeks. The stock started at 225. So y equals where we started, 225. Now, going by a rate of 25%, okay, well, if it stayed the same, it would be 100%. So it declines 25% every 2 weeks. So we'd subtract 25% from 100%. So every 2 weeks, we have 75% left over. That's what we multiply by, 0.75 to the x. So y equals 225 times 0.75 to the x. Okay? It's kind of like that growth one. It's a growth one. That's just the way that's the better way to think about it, is the way that I showed you. Okay? And if we have more of those types, we'll keep doing those. Alright, maybe we'll just do 4 at a time. So let's do one more. A weed species triples in 6 days. Triples is timesing by 3. A field started with 12 weeds in the early spring. Okay? So y equals, we have 12 weeds. They're tripling every 6 days. So times by 3. And we get to the x power. Alright? Now, it's 6 days, but we're thinking in terms of this would be like 6 days. This would be 12 days. That's a good way to think about those kind of things. Okay, so the last one was 12 times 3 to the x. Okay, so now let's graph these. So the first one, 20 times 2 to the x. Okay, so I'm going to have to, so 0 would start at 20, then we're timesing by 2, so it would be 40, then 80, then 160, and so on, right? So to graph those points, I'm going to call this, let's go by tens. So that would be 20, 40, 60, 80, 100, 120, 140, and 160. So at 0 we'd have 20. At 1 we'd go up to 40. At 2 we'd go up to 80. So you can see I'm getting that curvature now. 3 clear up to 160, and so on. So we draw our line, and that's how it would look for that one. Okay? Alright, now let's do the next one. Okay, so on this one, let's call this 500. Okay? And we'll do this one in that blue, lighter blue. So we start at 500. Okay? And then we're cutting it in half. So at 0 we're at 500, 1, 2, 3. Then we're timesing by a half. So this would be 250, then 125, then 125 divided by 2 would be 62.5. Okay, so at 0 we start at 500, so we're counting by 50s here. So this would be 250. So at 1 we go to 250, then this would be 125 would be in the middle here. Be like right here, and then 62 would be closer, so it would be coming down, and it would never go across that y-intercept. It'd go like that. Okay, so that is the second one. So we got those two done. Okay, now next up we've got 225 times 0.75x. Let's try to graph that one on the same part. So I'd go 225. Well, what am I doing? Be 225, and then we're timesing by 0.75 each time. So 225, I'm going to need a calculator for this one. So 225 times 0.75 would give us 168.75 times by 0.75 again would give us 126.56 times by 0.75 again will give us 94.92. Okay, so 225 would be right about here starting. 168 would be here. 126 would be almost to the same place, wouldn't it? A little taller. And then 94. So you see this one would have a curve kind of like that. I didn't do a very good job of estimating. Well, that was even a worse curve. So look. Something like that. That probably should have been a little lower. Okay, so there's two graphs right there. Alright, let's take a look at our last one for this group of 4. Alright, so we've got y equals 12 times 3 to the x. So, we start out at 12. Okay, then 12 times 3 is going to give us 36. So that's 0, that's 1, that's 2, that's 3. Okay, 36 times 3 is 108. 108 times 3 is 324. So you can see we're getting pretty high pretty quick. So, if we counted by 50s, that'd be 100, 200, 300, 400, 500, right? Okay, so 12 would be clear down here, wouldn't it? 36 would be only slightly higher. At 2, we have 108, so we're a little above. 3, we jump up to 324. Okay, we could probably go one more. What's 324 times 3? 972, which if we kept going, that would go up, clear up to about here. And there we go. There's our graph. Okay, see how it's got that curve? See how it climbs. Alright. So, let's take a look now at the other ones. Alright, so back to the last 4. So let's see if we can knock out these last 4 here. So the population of a big city is increasing at a rate of 2.5% per year. So that means they have their population of 100%. The people, if they had no kids, they would stay the same. Well, we're increasing that by 2.5% every year. So 100% and 2.5 is 102.5%. Turn it into a decimal, it's 1.025. That's our growth. Okay, and we start out with 67,000. So 67,000 times 1.025 to the x is our equation. Okay, 8. And investment, 8, 9, and 10 are all about investments. Okay, so now there's a formula for this. Okay, and it's the amount you have is equal to the principal, what you start with, times 1 plus, you know how we do the 100%? That's that 1 plus the rate over the number of times it's compounded. Okay, to the time times the number of times it's compounded. Okay, so if we, and those compounding is thinking n would be, if n was 1, that would be 1 year. So semi-annually would be twice. So it would look like this. So A would equal our principal 1,000 times 1 plus 3.7 over semi-annual, 3.7, we need to turn that into a percent, 0.037. Okay, over n, which n would be 2, to the t. Okay, t would stand for time. That a would be like y, so we could change this, and we can simplify this. 0.032, 37 I mean, divided by 2, plus 1 would be, so we could rewrite this as a equals 1,000 times 1.0185 to the t. Okay? We could simplify it by that. And then we could times that by how many years. Okay, and you could even change that to y equals 1,000 and all this stuff. Okay, now what I think we're going to do on these last ones, don't worry about graphing these last ones, and I'll tell you that when I assign this out, but I'll show you on the calculator how we can do that, because these are difficult to graph and to be accurate with. Okay, so let's not worry about graphing these ones. Let's just worry about the equations. So now number 9, we're going to use the same equation, but this time we start out with 600, okay, and we earn interest 2.9, so 2.9 would become 0.029. It's compounded quarterly, that means 4 times in a year, so 1 plus 0.029 over 4 to the t. So we go 0.029, divide that by 4, okay, then we're going to add 1 to that, and that would give us a equals 600 times 1.00725 to the t. Or we could make that x as well, and this y. Same thing, okay? Same thing. Let's rewrite it so we can graph it, though. So x and y. Now the last one would be an investment of 3,000, so A equals 3,000 times 1 plus 1.4% would be 0.014 over compounded weekly, that's 52. So 52 weeks to the t. So we'd change it to y equals 3,000 times, so we'd go 0.014 divided by 52. And that, that's like 0.000269231. Okay, that's a really small number. Plus 1 would be that same thing, but 1.000269231 to the x. Okay, so there's those. I'll hurry and graph them so you can see what the graphs will look like on all 4 of these ones and show that to you guys, okay? Alright, so taking a look at these 4 equations, I graphed them on Desmos, that one we used in class. Here's that first one. Okay, you can see these numbers are enormous. And then I graphed the other 3 together, those 3, and you can see them right there. That's kind of how they would all look together on the same part. So you may notice all of a sudden some music started playing. I'm not in my classroom, I'm somewhere else. Extra credit if you can figure out where I'm at.